Okay, so let's start. Welcome back to our final session in this interesting event, and thank you for being here. We have with us Frank and Ashish from AVI Network? Avi from AVI Network, and they are going to talk us about networks. Interesting network topic. So, yeah, please go
Thank
ahead.
you. Gentlemen, thank you for being here. Gentle ladies also, of course. I'm very happy to stand here again and to able to promote OpenStack. I was last year in Copenhagen at the OpenStack days. At that moment I was working for another company. And I'm involved with OpenStack now for 5 years. And I saw also OpenStack changing, growing. And I think that we are now on a level where I would say that OpenStack is in production in many places. But that's also one of the things I saw in my experiences in the past is from what's good and what's bad on OpenStack. And one of the things I really had problems with in the past with OpenStack is the fact is, and maybe some people know the name Silometer. And with OpenStack sometimes, if it works, it's all great, good, fantastic, perfect, everything going right. But the moment that something goes wrong, you have to troubleshoot. And I think with troubleshooting, especially in an OpenStack environment, it's very difficult because there's so many things that go wrong. You don't know where to troubleshoot. So one of the things I learned in the past as a system administrator on Linux in the beginning, later on now with cloud computing, is how measuring things, analytics, data. And that I think is one of the important things that we have to do at the moment. Because many people these days are talking about DevOps. But I learn a lot about dev, you know, virtualization, containers, now containers in OpenStack, agile, many releases a day, things like that. Very nice, but everybody forgets about the ops. And there's one thing I learned at my 8 years at Red Hat, where I sold free software. If it ain't running production, it doesn't make money. So one of the things I think very important, especially in production environments, or even when you go from dev to ops, production, making money with something, is making sure that the ops have the tools to analyze, to see what's going on. If a customer calls, I got a problem. I'm very happy here to have invited my friend here, Ashish, our Director of Product Management for Avi. He will talk about Avi, the integration with OpenStack. Afterwards, as promised, we'll do a demo where we'll create a load balancer inside an OpenStack environment, complete integration, and then we do some troubleshooting. I hope you will enjoy the session. Ashish, the floor is yours.
Good afternoon, everyone. So thanks, Frank, for setting it up. My name is Ashish, and what I'll start with is, I'll talk a little bit about how AVI Networks product works, but to add to what Frank said, right, the challenges in OpenStack production deployment are performance monitoring, analytics, security, getting OpenStack deployment to production grade. And why is it hard? It's hard because two things. The built-in tools in OpenStack, such as HA proxy, which is integrated, it's easy, it's there, it's easy to work, but it's not enterprise grade. It's not ready for production deployment. Your ops team is not going to back it up, because how do you troubleshoot if things go wrong? How do you do enterprise grade load balancing with content switching and high performance SSL? Okay, so then what do? Your ops team is used to deploying appliances in a pre-OpenStack environment, right? F5 load balancers, Citrix appliances, or maybe other appliances. What's the challenge there? Yes, they have all the features. They don't have integration. They're not built for cloud. They were built 20 years ago for the client-server architecture. You cannot retrofit their architecture to a cloud environment. That's the problem we solve. We solve the problem of something that's built for cloud, that's natively integrated with OpenStack, gives you the enterprise-grade features, performance, security, monitoring, and analytics. So that's basically what Avi does. How does it do that? What did we do differently to build the next generation architecture? What we did was, if you look under the hood of a classic load balancer appliance, which you deploy is typically active standby, there is a control/management plane, and there is data plane, right? That's how every appliance has. We separated the two. We had a separate centralized control plane. We call it Avi controller, nothing fancy there. And a distributed data plane fabric, an elastic set of software load balancing fabric that is automatically and centrally managed by AVI controller. So operationally, you have one logical load balancer. Of course, it's HA, active, 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 but it's logically one. Performance-wise, it's an elastic fabric. Think of Amazon ELB, but running on any cloud, be it OpenStack, be it something else. Second, any environment. It's software. All it needs is x86. Bare metal? Sure. VM? Sure. Docker container? Sure. Public cloud? Absolutely. It's software, right? If you don't need purpose-built appliances for applications, your applications run on commodity x86. Why should your network services not be running on x86? That's the fundamental principle. Third, these service engines or the load balancers are centrally managed by AVI controller, which means you don't individually log into any of those. You configure your VIPs, your policies, through APIs, which on top of it, which you have UI and CLI, on the controller. Controller intelligently decides, okay, built on the tenancy model, where should I spin up a load balancer? Do I have enough capacity? Should I scale out? Should I scale back in? Should I auto-heal based on HA? That's controller's job. And how does it do that? It has real-time built-in analytics. Why? Load balancers are proxies. All the traffic goes through them. So we collect hundreds of logs and metrics, push it up to the controller, which runs a big data analytics engine. Not just for pretty dashboard, but for a closed loop. And how does it achieve that automation? Through integration with the APIs to OpenStack, through EC2, through Azure, through vCenter, through SDN controllers, you name it. With Ansible Playbook, Python SDK, Heat templates. It's all built into the solution. So think of this as a complete elastic, intelligent fabric that you deploy and it runs. That's an enterprise-grade solution. So let's see how that works in OpenStack. So again, the controller deploys as Nova instances, 3 for HA. You point it to both the Neutron API and Keystone API, Keystone endpoint. That's it. It downloads all the tenancies and users. It spins up the load balancers as Nova VMs. It talks to Neutron for plumbing the VNICs on the right port group. It supports LBAS APIs, of course, V1, V2, Heat templates. And it has a built-in Horizon dashboard integration. So you don't even have to go to a separate tool. The AVI dashboard is integrated into Horizon. Okay? So it's fully integrated native solution that gives you that enterprise-grade features that I talked about. And you can deploy per-tenant load balancers. Each tenant can have its own SLA, active, active, active standby, small load balancer, large load balancers, you have it. It's a truly next-generation elastic fabric. All features. L4, L7, SSL, auto-scaling, global server load balancing, DDoS mitigation, SSL termination, web application firewall, everything. Fully multi-tenant, has built-in IPAM and DNS if you want to use it, has 100% REST API, built-in application monitoring and analytics. Just one SKU, just one product. Just works everywhere, does everything. That's the idea. Last slide, and I hand it over to Frank for the demo. A common question is, what about performance? This is software. Don't you need custom ASICs for high performance? Well, let me answer it this way. Does Amazon, Google, Facebook, do they use custom ASICs for load balancing? They don't. Then why should you? It's a myth that the hardware vendors have propagated. Then you need ASICs. The load balancer can be as small as 1 vCPU core. Get you 5 gig of raw throughput, 1 gig of encrypted throughput, 2500 SSL TPS. Your building Lego block can be as big as 2, 4, full 30 or 40 core servers, core server, giving you 80 to 100,000 SSL TPS. And then you can scale out. Have lots of these, centrally managed by the AVI controller. I'll give you an example. One of the large payment processing companies in the US, it's global actually, they wanted to test 1 million SSL TPS in public cloud, in software. With AVI, we achieved that from 0 to 1 million SSL TPS in 8 minutes. Scale out. And when you're done, scale back in. That's the beauty of software-defined architecture. Okay. With that, back to you, Frank. You can download for free, by the way, if you want to try it in your environment. It's available for free to download on our website. Hand it over to Frank for a real live demo, so you can see it before you believe it.
Hello. Hello. Hear me? Who knows this? What is this? It's Horizon, okay? Plain Horizon. And for example, okay, so I got my compute power, everything what I need, and here, for example, I got my load balancers. Voila. Do a refresh, see that everything works. Okay, let's create a load balancer, a VIP, with some backend web servers. Give it a name. Oh. OpenStack Nordics 2018. No, let's call it 17, you know. Descriptions. Let's get it the client subnet. Next one. It's a listener. Call it port 80 as a listener. Protocol HTTP port 80. Next. Okay. Pool details, methods. This is how we're gonna balance the traffic between. Round robin. Add some pool members. I got some web servers here. At 1, at 2. Okay. Next. Monitoring type HTTP. That's nice. Create load balancer. Okay. Oh, okay. Yesterday I sacrificed some animals for the demo gods, you know. It were plastic animals. But indeed, as you can see now, I created from the OpenStack dashboard a load balancer. And it says it's active, it's even online. So I did it from the Horizon dashboard, but you can also do it through the OpenStack API. So if people are in your company or in your team are working with OpenStack, they don't need to know Avi. So that's the nice thing. They can work with it thing. Now the nice thing is, and that's what we have here, that is the Avi dashboard, which my permissions was locked out. Oh, somebody changed my password. Probably because I'm on Wi-Fi. And now you see that there's a load balancer also created here in Avi. Okay, nice. That's good. Nothing special. But when we go back, like I said, if you really want to do the operations, and let's say this load balancer, this VIP here. Oh, wait. I go back, sorry. I forgot something. Where are my load balancers? We can associate a floating IP address to it. Let's associate an IP address to it. Let's see that it works, of course. So it really works. Now, the problem is, if it works, that's okay. But let's say that one of our customers, for example, are calling us and saying that it's slow, it doesn't work. We have to analyze it. The only thing you can see here in your Horizon dashboard from an OpenStack perspective is it's online, it works. It's not broken, but that's it. There's nothing more you can see from things. So now what we can do is go back really to a live service, for example. This is a live website where you can do the analysis from what that load balancer is doing. So people who just work with the OpenStack, they can stay in the OpenStack. The guys who are responsible for operations, for the networking part, can start analyzing what's going on inside that load balancer, inside that traffic management. Like I said, I know some people already saw this today with the demo on our booth, but let's do it again for some others. Let's say we have some customer who complained about being slow, that some things are going slow, you know. So what we can do here is analyze, for example, the end-to-end traffic between that customer, between our web servers, and see who has problems or not. Because you can see the service is up and running, it works, but probably the guys here with more than 1,000 milliseconds of delay ain't gonna be happy. Let's check it out who it is. And as we can see and analyze for every request that that guy has done in the past, we can see that guy is now coming from India And we can also see, for example, here, that the problem is not on the application, it's not inside the OpenStack cloud. The problem is the connection to the OpenStack cloud. So from that moment, we can start analyzing and not waking up the application boys at night. Now we're going to wake up the guys in India and the network guys from our teams to make sure that they restore or improve the WAN connection. One of those things can help because, like I said, we can also, for example, put alerts on it. For example, we can also, there's not alerts on it, but also if we go back to the service, this service is using one small load balancer. Sometimes we can now start analyzing that maybe we need more load balancers. Maybe it's the application is slow. Let's scale out. Let's use a heat template to scale up the OpenStack instances. Those are the things that, from my point of view, for operations is very important. To know what's going on, what the traffic is. If we go back to the analytics, or to, like I said, we can even go back in time. Like I said, we can do 6 hours. We can see the trends of the past months. For example, when we go here, the average response time is good. But for example, here, it was not the network. Here, it was the application who was slow. Even better, when people, certainly now in that DevOps world, start creating applications, because this is multi-tenant, and I got some right to some tenants, for example, the same like you have tenants inside an OpenStack, you give those people the ability to test and to benchmark their own applications and see what's going on. Because what if, from an operation point of view, and they're going to deliver a new application or a new version to you, the question from operations is going to be, what kind of resources do you need? How much? At that moment, those guys can all do some stress testing, some benchmarks, and we expect we need that kind of servers, and we get those response times. Same thing, also from if something goes down or is a problem, now you can really troubleshoot and analyze where it went wrong. Were the servers okay? For example, one of the things that we included in AVI is a health score. Here's a penalty on security, for example. Let's go to security. We can analyze the certificate. Look, it's a self-signed certificate, but also the TLS version, the SSL versions. This gives you a complete insight from end user to application, the traffic management through, what's going on. And the funny part is, it works out of the box in OpenStack. I think...
we can show even from... Even from an application developer point of view. So what Frank also showed right now was, as an ops guy, you can troubleshoot all that. One more screen here, for example, it tells you how your application is deployed, what type of pools it has, what type of network the backend servers are. One of the servers is down, why is it down? Looks like an ARP issue, right? So single monitoring dashboard. But that's all ops related. What about if you're a developer and you really care about A/B testing? You care about, is my application performing well? What should I focus on if I want to have a new version of the application? Well, you have pre-canned analytics on your right-hand side. So for example, you know all the transactions, which browsers they're coming from, or what OS they're coming from. So when you do the next version of the development, you need to focus on, you better test against these. Or if you're a security admin, and let's say you want to find out what are the different SSL versions this application's clients are using. Let's say you want to terminate, you want to stop using TLS 1.0 because a new attack has been discovered. No problem. You can, with a single click, you go to the configuration screen, you edit the profile, you create a new profile, for example, and we do that, and you can select or deselect. Okay, I just don't have any TLS 1.0. Done. Single place. The whole fabric can be implemented. Or you can decide, okay, what if I were to enable or disable certain ciphers? Is it perfect forward secrecy enabled? Does it have the better performance or not so good performance? What is the compatibility? As you make changes or select or deselect ciphers, it gives you real-time feedback to you. That's enterprise grade. let's discard any changes we made. And for example, if you have, if you're again an application admin, you're interested in finding out what type of response is my app generating. Okay, 200 is great. Why are there a bunch of 404s? What's going on? Let's troubleshoot that. You again filter the logs and then figure out which URLs are generating the 404s. Okay, there are a few of them, some tests, some index.html, but primarily a PNG file. Okay, so let's filter, because that's a problem. And let's figure out, is there tied to a specific backend server or it's across the board? Okay, it's only on one server. So again, you can troubleshoot missing pages down to specific servers, right? Very, very powerful tool. Okay. Again, I can show you a lot more things. We can keep going on, but let's pause, take some questions.
Yeah. Any questions?
Yes.
So you said this would work on any type of solution, so bare metal all the way to public cloud.
Yes.
But also, say you have some very large companies that have tens of data centers, or hundreds even, spread across the world, also utilizing public cloud from different vendors around. So would you, and if so, how would you be able to provide like one central place for the
Global server load balancing. So we do GSLB, where you typically you deploy controllers in each of the data centers, which then are federated for providing GSLB, and you can provide intelligent traffic management. So the individual service engine would be running in each of the data centers or public cloud, let's say running on-prem, running AWS, running Azure, maybe running on-prem in Kubernetes. And then those VIPs are then global server load balanced through GSLB based on business KPIs, like time of day, security, tenancy, cost, whatever, right? Yes, complete global solution. In fact, what I can do is I'll show you. So let's say you are from the Avi UI, you have much more power or API. When I say create a virtual service, first question asked me is where? Do you want to create in Linux server cloud, bare metal? You want to create in OpenStack? You want to create in Azure, AWS, VMware? Where do you want to create it? Right? It's all centralized. It's all available. More questions? Things like, let's say you want to create in a vCenter cloud from the same server. You give it a name. It's called demo 2. We also automatically can pick an IP, publish to DNS, right there. You don't have to even select IP addresses. You can, for the servers, you can say, well, this is the vCenter environment. So there's something different from what Frank showed. Where are my servers? Let's say they're on VLAN 100. We log into vCenter, grab a list of all the VMs.
So for all clouds, there's interaction between the clouds, you know?
Yes.
So it's not a one way from OpenStack to Avi or from Avi to OpenStack. No, it's both ways that they connect. Same thing with other clouds like from Amazon or an Azure at the moment, which is popping up everywhere. Even also one of the features, this is one of the things that is very powerful also, is like this is management of traffic from north to the south, you know? From client to the app. The nice thing is, for example, in Kubernetes environments, and I know a lot of you are using that or looking to use that, is the fact that you can even replace kubeproxy and make sure that you also do east-west traffic management between containers. So that's the universal thing. Is the fact is you can have people who just using the OpenStack get their load balancing and have it working, no problem. Keep it easy and simple using the APIs of OpenStack. The moment you want to do more, you can log in the Avi dashboard and get all the features.
Right. And also, the last thing I'll say is that it's easy to see the feedback. So let's say you want to put a security policy on the new VIP that I created. Let's say you want to say that I want to create a rule that matches on a path of an HTTP request that, let's say, ends with, let's say, where is the ends? It ends with, not equals, ends with PHP. I want to terminate the connection. That's your rule. Done. It figures out where to save it. Now let's actually go ahead and run some traffic. So I need to be on VPN though, but I can.
You should be on VPN.
You should be on VPN, Frank?
Yeah.
Okay. So I copy this.
Control N. Yeah.
Paste and go. That's a server I created. Now let's go ahead and say something.php. Not found. You go here. You look at logs. Significant logs. Okay. Oh, this is the wrong one. No, this is the right one, right? Yep.
You
this.
went the wrong address. You still had the wrong.
Thank you. That's why.
It's copy pasting on a Mac. It doesn't work. Put the buttons wrong. Put the buttons wrong.
No. Okay. Well, yeah. It's a wrongly mapped button, so that's why it. All right. No. Doesn't want to work. So demo2.demovip.avi.local.
Yeah.
Okay, let's try that. Demovip.
You see, it's not a movie, eh?
What was that again? Demo2.demovip.
Yeah.
Okay.
Demo2.
Otherwise, you can mark it and do CMDC.
Yeah. There you go. That's right. Now it's coming up. And now let's try the .php. My keyboard. Okay. Okay. Connection was reset. You can go here, refresh the logs, and it'll tell you that the connection was reset. Why? Because it matched the rule one that we just created. So basically, you can see what's going on. And not only that, in fact, as you do that, right, it tells you who did what configuration. Sorry, question?
Yeah, should.
Could you invert the rules so that you only allow, let's say, HTML and PHP, so that not some stupid developer has done a backup file of the database configuration in PHP and named .backup, so it will be indexed by search engines and such. Is that possible to invert the rules?
Yes, it is possible to invert the rules. It's positive security, yes. Allow only this, yes. Also, we have web application firewall, which basically you can do everything, including SQL injection or allowing whitelisting, blacklisting, cross-site scripting prevention, yes. And you get the same level of visibility.
It's even also have you can have your own create your own scripts with the Lua in Lua, you know, and that's the nice thing is you got in Avi you got two kind of scripts. You got control scripts which do alerting on the controller, but those Lua scripts will be sent to the service engine and resides there and help to manage the traffic over there.
And it also tells you right on the same dashboard, it tells you who made change. So it says Frank Wainsdott made a change. So somebody made a change and stopped working. You can go back and superimpose the config audit on top of the performance.
Actually, I have another question.
Sure.
Could you export the data or the log results?
Yes.
Other systems like
Splunk.
Yes.
Yeah.
Or Elasticsearch?
Yes,
Yeah.
absolutely. You can pull, you can push both. Both models are supported.
If I'm thinking on especially Elasticsearch,
Mm-hmm.
could you, do you need to parse the data through a log slash before, or can you just write directly to Elasticsearch?
We can, so right now there's a pull interface, so you can pull it through APIs.
Okay.
We use Elasticsearch internally as well.
Okay.
But yeah, so you can just pull the data as JSON blobs. Okay. All right, I think we are past time. If you have more questions, we still are available at the booth. Get a beer and then talk to us.
Yeah, I hope it was a useful 30 minutes.
Thank you.
Yeah. Okay, thank you.